Alright guys, hello again. This is chapter 10.2. Just a quick amount of notes so that we're ready to go tomorrow. In this case, in this chapter, we're learning how to solve quadratics. We learned how to solve quadratics in the last chapter, but we learned how to solve them by factoring. What I'm going to show you today, you actually will get the same answer that you get by factoring, but it's a different method that you can use. So in the last chapter, if I asked you to solve this equation, what I'm asking you to do is find out what x is. Well, we learned how to solve this because it equals 0. So we're going to solve it by factoring, and here you can find the greatest common factor, which is x, which you factor it out. And now you have x, you could set each equal to 0, and you get your two answers, which are 0 and -3. Well, let's take this same equation and let's graph this. So if I was doing this by hand, I would find the vertex by doing -b. In this case, the b is the 3, so -3 over 2 times a, which is 1, so over 1 times 2, which is 2. So you get -3 halves. Well, because you have a line of symmetry, which is a -1.5, I'm going to go ahead and choose to do this one on the calculator, which is going to make it a little bit easier for me. So I go to my TI SmartView, and I'm going to plug in my equation, which was, just go back, x squared plus 3x. So y equals x squared plus 3x. I'm going to hit graph. What you're going to notice about this graph, now you can't just go by what you see, but if you look right here, the graph, the parabola, comes down and hits the x-axis, what looks to be at -3, and then again at 0. And those are the two answers we got by factoring. Well, that's what happens when you graph. When you graph to solve a quadratic, as long as it equals 0, which it does, I can graph it, and wherever it hits the x-axis, those are the same answers I would get, and that's what x equals. Now, just to double check, one way we can use our calculator is we're going to go back to our calculate key, which is right here. So I'm going to go second, calculate. Now, we call the points where it hits the x-axis right here the zeros of the graph, because it's when x equals 0. I'm sorry, it's when y equals 0. So I hit option number 2, and it kind of looks like how we found the vertex. It says left bound, but what it wants us to do is go to the left of the point we're trying to find. We're not trying to find the vertex anymore. We're trying to find this point and this point. So let's find this point first. So I'm going to move my cursor all the way, and notice that as I'm moving it to the left, it's moving now up the parabola. So left bound would mean above this point right here, above where it crosses the x-axis. I'm going to hit enter. Right bound, I'm going to go below that point that I'm trying to find, which would be right about here. I'm going to hit enter, and the last one is I'm going to hit guess, and it gets -3. Of course, y is 0, because that's where it hits the x-axis. So one of our answers is -3, which, by the way, you got right here when we factored. So you do get the same answers. So it crosses at -3, and it also should, the other answer should equal 0, but let's go back and double check it. So I go second, calculate. It's the 0, so number 2. So left bound would mean, actually, if I'm moving to the right, I'm now moving up the parabola that way. So left bound would be before it hits the x-axis. So I'm going to go a little more to right about, maybe go down 1 a little bit. There you go. Hit enter. Right bound, I'm going to hit the right button until I'm above the point I'm trying to find. Hit enter and guess. I'm going to hit enter. And of course, you get the answer, the second answer right here, which is 0. Remember the same answers you would have got if you factor. So graphing isn't anything new. It's just a different way to solve. So instead of factoring, we're solving by graphing. So just a reminder that where it crosses the x-axis are your answers, are your solutions to what x could be. We call those roots. We also, as you now know, we call those zeros. They're the solutions to our quadratic function. So if you think about the different ways parabolas could be, if you look, parabolas sometimes can have no solution. Just like when we factor and we can't figure out the factors, sometimes they have a solution, but a lot of times they don't. So when a parabola doesn't hit the x-axis, like this parabola in black doesn't, we would say that the parabola, there is no solution to that quadratic. If you look right here over at the red, you can see that it crosses the x-axis twice. So this one will have two solutions. And remember, the solutions or the roots or the zeros are the actual, what the x-coordinate is, where it crosses. And right here, sometimes you might have a parabola where the vertex is actually on the x-axis. In that case, there's actually only one solution. This would be like if you were factoring and you got two of the same answers, like x minus 3 times x minus 3 equals 0. Well, when you set each of them equal to 0, you get the same answer twice. Well, that's kind of, if you were to graph that same function, you would notice that it had a vertex on the x-axis. So here's one more example of how you might, use graphing to solve. This is a, I made this up, but we're going to pretend that this is a quadratic function that represents someone throwing the ball up in the air. So again, x would be the time, and h of t is just a function. Time is going to be a function of how high the ball goes. The longer it goes, it's going to go up, and it's going to come back down. The question is going to be, when will the ball be 10 feet in the air? Well, in this case, I'm giving you the height. So it's going to be, I'm going to switch it around a little bit, 3x squared plus 5x plus 18 equals, when will the ball be 10 feet in the air? Well, this is just like factoring. Our first step is to always get the function equal to 0. So now I have negative 3x squared plus 5x plus 18 plus 8. Because 18 minus 10, and then 10 minus 10 is 0. Now that I have it equal to 0, instead of 0 equals, I could just think of 0 being my y, where it crosses the x-axis. So I can graph this function right here. And my answer is going to be, just as if I would have factored this, instead of factoring this particular quadratic, I'm just going to graph it. So I have in y equals, let me go back, I already forgot the function, negative 3x squared plus 5x plus 8. I'm going to hit graph. Now, one of the most confusing things about what algebra students forget is they think, well, this is right here where the ball hits the ground, and it's not. If you remember, we changed the equation. If this equation equaled 0, that's where the ball would hit the ground. But because we made it equal 10, and we moved the 10 over, these 2 points right here, the zeros, are actually going to be the answer to the question we're asking. It's going to be solving for x. It's going to be, what does x have to be in order for the ball to be 10 feet in the air? So I'm going to go ahead and find the roots or the zeros of this graph by going second, calculate, 0, enter. And it says left bound, so I'm going to move my cursor over. Now keep in mind, the first one, this is actually another important point. This answer right here is going to be when the ball is first 10 feet in the air. This is going to be when it's coming down and it's 10 feet in the air. So left bound, remember, is going to be, because if I move to the right, I move below it, I'm going to hit the left bound to be directly above it, hit enter. Now right bound, I'm going to move below it, enter, and guess enter. And it says that one of my zeros is at 2 and 6 repeating, 2 and 6/10 repeating. So that's one of my answers. And to find my other answer, I'm just going to go through that same process, but for the other one. Second, calculate 0, or hit for the zeros. It's actually option number 2. I'm going to hit the left button, and notice that left bound is actually going to be below the point. Oh, I went a little too far. Come up a little bit. It looks like I'll go one more. Let me go make sure it's left bound. So I hit left bound, enter, right bound. I'm going to hit the right button until it's above this point right here where it hits enter and guess enter. And the other one is -1. Well, in this case, -1 doesn't really make sense for a time. So when will the ball be 10 feet in the air? The ball is going to be 10 feet in the air after or I'm sorry, exactly, a little more than 2.5 seconds. And that's how we graph in order to solve this. And just to kind of sum it up, remember, you could have set this equal to 0, after you equaled it to 10, right at this point right here. You could have set this equal to 0 and then factored it. But instead, another way to get the answer, to get what x equals, we can graph.